Okay, after these notes, you will have a days 1 and 2 worksheet that you're going to work on, that the sub is going to give you, and you will need to return that to the sub by the end of the period. So you should be finishing that, submitting it by the end of the period. So no, that does not mean right after this, you're jumping into the homework. You're jumping into the homework when you're good and done with that worksheet. If it takes you to the end of the period, submit what you have and maybe write a little note on that saying did not finish. And that's okay. Just show me what you got to. Last class, we talked about circumference of a circle. We talked about arc length. Today, we're going to talk about area of a circle, how to find it, and then we're going to talk about how we find a portion of that area. This should hopefully be a little easier as long as we feel good on arc length. They're very similar concepts. Area of a circle is pi times r squared. Pi r squared. No, it is not pi squared. So I don't want to see pi squared times r. The only thing that's getting squared is your radius. So pi r squared. If I wanted to find the area of a circle with a radius of 2.5 centimeters, I just take my area, which is pi r squared, take my radius, and substitute it in. Now, I'm not expecting you to necessarily know what 2.5 squared is off the top of your head. However, if I ask you to leave it in terms of pi, you're going to have to just do 2.5 squared, 6.25, and then pi will just attach on at the end. Here, it doesn't specify though, so I got to give both. I give my exact form by just literally just showing my work, and then I take it to my calculator, 6.25 times pi, 19.63 centimeters squared. We're dealing with area again. Anytime you're in area, you're squaring your units. Pi r squared, you're given the radius. This is as easy as it's going to get. We want to find the diameter of a circle with an area of 113.1 square centimeters. Now, before I even start this problem, no, there is not some second formula where maybe I'm just doing pi times the diameter. No, 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 no. There is no formula for a circle that we're going to use that uses diameter for area. And that's that. Don't do it. Instead, what can we find? Well, we can find the radius, and then we know the relationship between the radius and the diameter. So I do exactly that, looking for my diameter, but I know that the area is 113.1 and that my area is pi r squared. So 113.1 is equal to pi r squared. Let's compare this to a simpler algebra problem. Let's say 20 is equal to 5x squared. Don't, and never would we here, take care of the x squared first. We would never take care of that x squared first. So we're not going to take care of the r squared first here. Instead, we have a number that's being multiplied to our r squared. That's the number that we have to get rid of first. So my first step, as it would be here, would be to divide both sides by 5. Or in this case, divide both sides by pi. Divided by pi, divided by pi. Goes away on that side, and I'm just left with r squared. 113.1 divided by pi is equal to r squared. If I wanted an exact answer, which in this case I do, don't just throw this into your calculator yet. Take the square root of both sides. The square root of r squared is just r, and my radius is the square root of 113.1 divided by pi. I get it. That's a mouthful. So I'd probably just ask you to give me the radius as a decimal. 6. 113.1 divided by pi is equal to r. Since we have a radius of 6, our diameter, which is what we're solving for, would be double that, 12. So area formula, you're only ever going to be working with your radius. Circumference is where we have both radius and diameter. Take a moment, try problem 1 and problem 2 yourself. Problem 1, find the area of a circle, you're given the radius. Problem 2, find the radius of a circle, you're given the area. So this one's not going to require that last step of finding the diameter. Pause the video, take a moment to try these yourself. Did you pause it? Are you lying? You better not be lying. You better have tried these yourself. Talking through them a little briefly here. Area is equal to pi r squared. You're given the radius. Just throw it in there. 4.5 squared is 20.25. Your area would be 20.25 pi, which is approximately 63.62. Area is equal to pi r squared, except in this case, area is 176.7. Divide by pi, take care of the pi first, then we take the square root of both sides to get r by itself. This would be exact, but I'm not often going to ask you to do that, right? So once you get to this step right here, just take the square root and tell me what you get, 7.50. Okay, that's just dealing with area, which is, again, is probably something that you've seen before. I'm hoping that it's something that you've seen before. To find the area of a sector, this is just, as arc length was, a portion of your area, right? So I have some x degrees. That's going to be the same measure as my arc. And we're going to scratch the cross multiplication formula and instead just already solve for our sector. Arc over 360, that's arc measure over 360 times my area. If you would like to, you can take a second and write these down. Area is pi r squared. We only have one formula, so if you want to just get that and just write this down here, that's fine by me. Find the area of the sectors formed by angle UTV. There's two sectors, UTV, there's our angle. We have sector created by arc UV and the sector created by arc USV. So we'll have two arcs that we're finding. What do we know? Well, I know that my x is 70, right? My arc measure is 70, and my radius is 8. And I'm finding my sector area. Area of that sector is equal to x over 360 times pi r squared. Substitute. My x is 70, my r is 8. 70 times 360, 70 over 360 times pi 8 squared. 8 squared is 64. 70 over 360 is 7 over 36. If I asked for my exact answer, which I don't even know if I put here. Nope, I did not. Let's see, let me just use Desmos here for a moment. If I wanted my exact answer, I would need to just multiply that 64 pi up into the numerator, and I would get 448 pi over 36. And then I could reduce that 448 over 36. In this case, right, this would be a problem where I say to round. So I should at least have this work shown as I'm going through. 7 over 36 times 64 pi gets me approximately 39.10 inches squared. Now I want to find the area of my blue sector, which is the area of everything remaining in this picture. The first thing that I have to do is figure out what this angle is. I'm going to give you about 3 seconds to figure out what that angle is. We shouldn't have an issue doing it. Good, that's what I got too. It's 290 degrees. I know that this is a full rotation, so all that's got to add up to 360. That's 70, that's got to be 290. The area of that sector with an arc measure of 290 And it still has the same area, right? So we can still use 64 pi because it still has a radius of 8, right? So if I want to go through and write pi times 8 squared and then get 64 pi, that's fine. But I already know what the area is. I can just substitute it. 290 over 360, that's 29 over 36 times 64 pi. If I wanted an exact answer, I would multiply 29 and 64 and then bring the pi up there as well. But in this case, I didn't even do it, so it's okay. I would get approximately 161.97. If I add up those two sectors together, I should get something that's pretty close to the area of this entire circle. So if I just did pi times, let me use a different color, pi times, excuse me, 8 squared, pi times 8 squared, what does that get me? 201.0619. If I added these two sectors together, I should get something that's close to the area of the entire circle. That's a good way for you to check yourself as you continue through these problems. Okay. Take a moment to do problem 3. If you really want to challenge yourself, you can do problem 4. It's going to work out pretty similar to problem 3, but if you just want some extra practice, go for it. Right now, pause the video and give problem 3 a try. Well, don't just wait for me to talk. Actually, pause the video, and then I'll show you what the solution is. I could call out multiple of you in class that are not pausing the video, and you're just waiting for me to go over it. Don't do that. Try it. You have everything you need. You have your x, you have your radius. You have the arc measure, you have the radius. So actually pause it and try it. Okay, fine. Don't pause it then. Choice is yours. If you want to check and see what you got for those of you that actually did pause it, great. Hopefully you got 205 and 410.50. For those of you that didn't pause it, you're just waiting for me to go over it, well, this is for you then. 120 degree angle means I have a 120 degree arc, so my x is 120. My radius is 14, so pi times r squared would be pi times 14 squared. This reduces to 12 over 36. 14 squared is 196, and I just multiply that to pi. 12 over 36 reduces even further to 1 over 3. If you're just working in Desmos and you put that, you'll get 1 over 3. I could, if I wanted an exact answer, bring that 196 pi up to the numerator, and my exact answer would be 196 pi divided by 3. And then I would reduce 196 over 3 if I could. But in this case, I'm only interested in the approximate area, which would be 205.25. To find the area of my blue sector, which is formed by arc LMK, I'm going to need this whole angle, which in this case is 240 degrees. 120 plus 240 has to add up to 360. That's how we can guarantee it every time. 240 over 360 is equal to our area, or sorry, not equal to our area. 240 over 360 times our area. We already know area is 196 pi. 240 over 360 is 24 over 36, which is just 2 over 3. So if you're just continuing to reduce, great. If you forget to fully reduce, and you would give me 24 over 36, or maybe 12 over 18, it's fine, I'll live, but I want you to try your best to get it all the way down. 2 over 3 times 196 pi. Again, if you want exact, if I asked for exact form, you'd multiply that up. Don't care in this case. 410.50 feet squared. If I checked the actual area for the entire circle, which in this case is 615.75, I just know that off the top of my head. No, the radius is 14. pi times 14 squared is 615.75. These two add up to exactly 615.75. Good way to check myself. Problem 4 is extra practice. The only problem where we're going to be working backwards here is going to be this one. Working backwards with area can be a little tricky because you do have the r squared if I wanted to find the radius. But if I'm just finding the area, I could just leave it as a in my equation. My sector area is 48 feet squared. My arc measure is 135. So I substitute. Area of my sector is 48. X over 360 is 135 over 360 times my area. Let's see if I did it right in my notes. I didn't even do it how I want to, so I'm going to go back through it. I didn't leave that answer there, though. 135 over 360. What I can do is leave that as a reduced fraction, which would be 3 over 8 times my area. I could bring my area up to the numerator, so I have 48 is equal to 3 times a over 8. How do I get 3a by itself? This is where I'm going to multiply 8 to both sides. 48 times 8 is 384. If I multiply the right side by 8, it's going to get rid of the division, 3a. If I take that 384 and I divide it by 2, I get an area of 192. In this case, feet squared. Moment of truth. Oh, I must have done it wrong the first time. Oh well. I want you to try the next one. Give it your best go. I want to find the area of this region that I have to paint. There is a circle involved. Just give it a try. Humor me while I go through and make sure that I actually did this problem right before I have to remake this whole video. All right, we're going to forget that this problem even happened because I made a mistake somewhere along the line and I can't even figure out where. So we're going to jump back to it. This is what happens when I don't trust my work. Erasing it. Let's find where I messed up. Sector area is 48 feet squared. Your measure is 135. 135 over 360 is still 3 over 8. So 48 is equal to 3. I'll just bring the a up over 8. If I take 48 and I multiply it by 8, I have 384 is equal to 3a. Divide that by 3, and I get 128. Well, I can't type because I did that exact thing before and I got something different. So, oh well. Hopefully you noticed that mistake and didn't just continue on. If you tried this problem, good for you. Going through it, it's a lot. We can talk about it more next class. I don't want you to worry about a problem like this too much for today. Right now, I want you to give these last two problems a try. One of them is working backwards. I give you the sector area, find the area of circle H. Here, you might be able to find the area of this whole figure here. I want you to give that a try too. Take a moment, pause the video, and give that a try. Hopefully you actually paused the video. Hopefully that caught you off guard if you were just waiting. Don't just wait. Try it yourself. Okay, find the area of circle H. Sector area is equal to x over 360 times A. Sector area was 214.37. Your measure was 85. I didn't even reduce 85 over 360 in this case. If you did, your work will look like this. I will show it to you just in case you decided to go the longer way of reducing your fraction. I didn't need an exact answer, so I wouldn't necessarily need you to do that, but I'd love if you did. 85 over 360 is 17 over 72. So I have 214.37 is equal to 17a over 72. I would multiply both sides by 72. This one I can't do in my head. 214.37 times 72. 15,434.64 is equal to 17a. I divide that whole thing in both sides by 17, and I get an area of 907.92. And in this case, it would be meters squared. So hopefully this shows you that regardless, even if you don't reduce your fractions, I would multiply both sides by 360 and then divide by 85. I'm still going to get down to 907.92. For this problem here, we have two shapes that we need to find the area of. We have a semicircle with a diameter of 30, and we have a 30 by 30 triangle. So that's two shapes you got to find the area of. Find the area of your semicircle, add the area of that triangle. Semicircle, if I wanted the entire area of that entire circle, I would just do 2 pi times the radius, but I want half of it. So that's 2 pi, or sorry, not 2 pi times the radius, pi r squared. Pi times 15 squared. I know this is 15. I know that that's 15 because the whole thing is 30. Pi r squared divided by 2 plus area of this triangle would be a 30 by 30 triangle. So 30 times 30 divided by 2 gets me 450. Oh my gosh, I'm losing it. 15 squared is 225. 225 pi divided by 2 plus 450 would get me 803.43. Again, I hope that you took a second to try these two problems out. This is definitely where some of us could be at. I'm hoping that some of us were able to reason and get this one too. Okay, as I mentioned before when I started this video, the sub is going to be passing out a worksheet. You need to work on that worksheet. Submit what you can. Show your work. I want to see where you are at after these first 2 days. There's a little bit of sector area. There's also a little bit of arc length on there as well. Best of luck. Email me with any questions.